Hello and welcome to Empowered Learning. This video will be about finding the sum, difference, product, and quotient of two functions, evaluating those types of functions, and figuring out from a graph what the domain and range of those functions would be. So for our first problem, we have two functions that were given, and from this, we want to create this new function and evaluate it at the x value 8. So the first thing that we want to talk about, just to review, is whenever we say something like this, this is abbreviated shorthand notation for we want to do the sum of two functions. Of course, if we want to do subtraction, then instead of this being plus, this would be minus. If we want to do the product of two functions, then this is a shorthand notation for it, and this is just f of x times g of x. And of course, the quotient of two functions, the shorthand notation for it is this. Now notice that with the product, I did not say this. Although this is another way of doing it, the reason why we avoid putting this multiplication dot here, the reason why we avoid that is because that dot there looks a lot like this, depending upon how small you write your circle. And what this is the composition of two functions. Mainly, we take the function g and we stuff it into f. That's a totally different concept than what we're talking about in this video. So here, to keep the confusion down, we just write the letters next to each other whenever we want to do the product of two functions, and we put an open circle here whenever we want to do the composition of two functions. So I want to make sure that we know that before moving forward. So now that we know that, for this situation, we know that g plus h of 8 is just going to be g of 8 plus h of 8. And all we need to do is figure out what g of 8 and h of 8 are. So if we come here, g of 8, we just plug in 8 everywhere where we see x. And we see that this ends up being 0 when we work it. H of 8, we just plug in 8 everywhere where we see x. And that ends up being 15. So here we know that g of 8, 0, plus h of 8, 15. Answer is 15. And that's how we evaluate the sum of these two functions, evaluated at x equals 8. So for our next problem, we see that we want to evaluate the difference of h and d, evaluated at -7. So again, we know that this means that we're going to do h of -7 minus g of -7. If we evaluate h of -7, then here we're just plugging in -7 everywhere where we see x, and we see that we get -4. If we do the same thing for g of -7, then of course if we plug in a -7 where we see x for g, we see that we end up getting square root of -15, which is an issue because we know that we cannot take the square root of a negative number and get a real number out. So in other words, we know that -7 is not in the domain of this particular function here. In particular, we know that x minus 8 has to be greater than or equal to 0. So we have to pick values of x that are greater than 8 if we're going to plug in values of x into this function here. -7 doesn't fit that. And so in this case, that means that the function value doesn't exist because we got a real number being added to a number that's not real. All right, so for question 3, this one's kind of long, and I'll rewrite these functions here just in case you can't see them that well. And so we're asked to find the domain of all of these functions, as well as find what those actual functions end up being. Excuse me. And so what we're going to do is we're actually going to do this backwards. We're going to find out what the sum of f and g, difference of f and g, product of f and g, product of f and f, quotient of f and g, and quotient of g of f is first. We're going to look at that, and then from there we're going to figure out what the domain of those functions will be. So start off here. We'll start off with the sum. So here we know this just means add f of x and g of x together. And literally this will just mean x minus 7 plus square root of x plus 8. If we do the difference, only thing that's going to be different here is that here we'll have a subtraction sign instead of an addition sign. If we do the product of f and g, then we're just multiplying these two functions together here. And we'll keep things simple and just literally leave it like that. If we take the function f and basically do the product of itself, then you have f of x times f of x, which is just this times itself. So that would be x minus 7 squared. And we could keep it like that, but if you wanted to FOIL it out, of course, let me go ahead and actually do it. So for those of you that actually want to FOIL this out, it would be x minus 7 times x minus 7, which here x times x is x squared. X times negative 7 is negative 7x. And negative 7 times x is a negative 7x. And negative 7 times negative 7 is positive 49. And that will end up being x squared minus 14x plus 49. Depending upon how you may want to type this in, you may want to try typing it in this way first. If it doesn't accept that, then of course type it in this way if you're working with MyMathLab or MyLabs Plus. All right, so now we also want to figure out what the quotient of these two functions would be. And of course here, if we do f first, so our function f is just x minus 7. So this would be x minus 7 divided by square root of x plus 8. And then of course, lastly, we would have g of f of x, which we would just flip the places of these. And so that will be square root of x plus 8 divided by x minus 7. Now that we have all these down, we want to talk about what the domain of each of these will be. So whenever we find the domain of a function that comes from other functions, for what we're working on right now, we have two restrictions that we need to take into account. The first thing we need to make sure of is this, and I'm going to put it in these symbols here. And so what this means is that in order for us to figure out what the domain of a function is, we want to figure out what can't be in the domain, because that's probably the easier way to do it. And here what I'm saying is, if I take an x value and I plug it into a function and I get a result of 0 in the denominator of that function, then I know that that x value is not in the domain of that particular function. The second restriction that we're looking for is whenever we have a result of having negative numbers under an nth root. And let me get that back here. Oops. It's going a little haywire here, so just give me a second. Where did we go? All right. Okay, sorry about that. So for here, what I was trying to say earlier is that our second restriction is if we have some x value that we try to plug into a function that has an even nth root in it, like a square root, fourth root, sixth root, and we end up getting a negative number, then that x value or those x values can't be in the domain of our function, because we can't take the even nth root of a negative number and expect to get a real number out as an output. So with that being said here, we want to look at what we have and note where we may have those issues for our functions. Now, in order to correctly figure out where you're going to have a situation like this for your function, it is my opinion that you need to look at what's called the raw form of the function in trying to figure out the domain. So what I mean by the raw form of the function is looking at this exactly at the point where you actually substitute in what your old functions are to create your new function. So for f plus g, it's right here. And f minus g, also right here. And f times g, right here. And f of f times f, right here. And for the last two, let me scroll down, it would be here. And for this one would be here. Now, for this particular example, it seems pretty obvious, but there are other examples that you'll do where you will actually have to consider, once you actually go in and plug in what your old functions are to create your new function, you may have to do some algebraic manipulation to it. Okay? And so by doing that, that makes the function look different, and thus the domain of the function try to appear to be different. But the thing is, if you look at it at your new function in terms of what it is as its raw function, you see everything. Okay? Now, for f plus g, f minus g, f times g, all of these are going to pretty much have the same domain. Okay? So for the x minus 7 part, there is really no restriction to it. But of course, for the x plus 8 part, square root of that, we know that whatever's under the radical has to be greater than or equal to 0, because we can't have a negative number under an even nth root. So if we can't have a negative number, what we can have is a positive number or a number that equals 0. Okay? So that means here, if we subtract 8 from both sides here, that we'll pick values of x that are, let me do that again. So we'll pick values of x that are -8 and higher. Okay. So for the domain for f plus g, f minus g, f times g, all those, the only restriction that you have is that your x values have to be greater than or equal to -8. So here, to put that in interval notation, that will be this for all of these. Oh, sorry, not for that, because that's just for f and g. Forgot that we had to find that first, so let me erase that. So for our function f, which is just the x minus 7, the domain of that will be all real numbers, because, and I'll go back up here, x minus 7 doesn't violate plugging in, because there's no value of x we can plug in and make the denominator 0. And here we don't have a square root or anything like that. So Domain of f is all real numbers. For g, we know that this particular function here, the x plus 8 has to be greater than or equal to 0, like we said down here. And of course, here this means that the domain of g is all values of 8, all values of x that are negative 8 and larger. Okay. All right, so for f plus g, the only restriction is going to be the same one as it is for the function g. And for minus, same thing. For f times g, same thing. For f times f, we notice here that, again, we're not dealing with any square roots. We do have something squared, but there's no square roots. So we don't have the second restriction to worry about. And of course, we're not going to plug in anything that makes our denominator 0. So domain of f, the product of f and f is going to be all real numbers. Now, for the quotient of f and g, if you notice here, the numerator, if we plug in a value for x, that's a real number, we'll get out 1, so we have no problem there. But for the denominator, of course, we have to remember that x plus 8 has to be greater than or equal to 0. But we know that since this is in the denominator, we cannot have x plus 8 equaling 0, which means x can't be equal to negative 8 either. So taking these two things into account lets us know that x can only be greater than negative 8. And of course, again, I'm saying that because we know any expression that's under a square root sign, that expression has to be greater than or equal to 0, which in this case ends up being x is greater than or equal to negative 8. However, we can't have the equal to part because if you plug in negative 8 here, negative 8 plus 8 is 0, and square root of 0 is 0. And you can't have 0 in the denominator. So that's why we have to exclude negative 8 in the domain of f divided by g. Now for g divided by f, this one is a little different. We actually have both restrictions in this case. So here, since the square root of x plus 8 is in the numerator, we know again that x plus 8 has to be greater than 0, which, according to what we saw here, x has to be greater than or equal to negative 8. But simultaneously, we see that we have x minus 7 in the denominator, and if we plug in a 7 here for x, we know that that will create 0 in the denominator, which we can't have. So in addition to that, we know that x cannot equal 7. Okay? And we know that because, and I'll write this formally here, we know that because we know whatever the denominator is, it cannot be equal to 0. So if we add 7 to both sides, we see that x cannot equal 7. So we have this condition and this condition we have to meet simultaneously. Okay? And so if we meet both of those conditions simultaneously, then what this tells us is we can choose any number that's greater than negative 8, but we have to skip 7. If we were to draw this on a number line, it would look something like this. So you would have all these numbers here, but when we got to 7, we would have to skip it. And in interval notation, that would look like this. Going from negative 8 on to 7, parenthesis means we exclude, do the union to connect, and then from 7 to infinity. Okay? And so this is how we evaluate the, we'll create these new functions from the old functions and figure out the domain of these functions. All right, so for our next example, we're given the graph of two functions, f and g. And what we're asked to do here is figure out the domain of f, the domain of g, and the domain of the new function f plus g. Okay, so if we look at the domain of f, we see that f starts at the x value 2. It stops at the x value 11. And since we have no holes, breaks, jumps, or gaps, then it's going to include all values from -2 to 11, including 2 and 11. So we put the brackets on the ends there. For our function g, we see that our function g starts at the value of x equals 1. Here, let me get rid of this. So it starts here at x equals 1, and it ends at x equals 10. And again, we have no breaks, holes, jumps, or gaps here. So we know that our domain is all the values from 1 to 10, including 1 and 10. For the domain of f plus g, we know that if we look at this graph, we have to have a defined value for the function f and the function g at those x values. And so a simple way to put that is we're only going to have defined values for f plus g wherever these two graphs overlap. Okay, so as you can see here, from 1 to 2, only g exists and not necessarily f. So both of these graphs start to overlap each other at x equals 2. Here. They start to overlap here, and they stop overlapping here. So everywhere in between 2 and 10 is where they overlap. So the domain of the new function should be from 2 to 10. All right, so we're given a graph of f and g again, and what we're asked to do now is to find out what the domain of g divided by f is, okay, or the quotient of g and f. So again, g and f can only exist, the g divided by f graph can only exist and be defined for places where 1, the graphs overlap, and 2, when the function f is not equal to 0. Okay, so let's take care of the overlap part first. So both of these graphs overlap each other starting at x equals 2, and it ends at x equals 11. Okay, so for right now, we'll say that domain is from 2 to 11. However, the other condition is that we can't allow our function f to equal 0. And any value of x where our function f is equal to 0, we have to exclude that. So if you look here for f, we see that right here, when x is equal to 3, your y value is 0. So we can't have that. So here, what this means is that we can have any number in between 2 and 11. We can have any number, again, from 2 to 11, but we have to skip 3 in this case. So the actual domain for this is not going to be what we see here. It's going to be every value from 2, but we have to skip 3. And of course, the parentheses here mean we exclude 3, and the union is just connecting these two separate sets of x values. And we keep on going until we get to 11, and then we have brackets. So that is what the domain of our new function g divided by f would be. All right, so I wanted to circle back and do a couple more of these evaluation problems just so that you can see some different results other than just an actual answer. So for this one, of course, we know that this f plus g of x is just f of x plus g of x, and we want to evaluate that at 3. So in this instance, we know that f plus g of -3 would just be f of -3 plus g of -3. And we need to figure out what f of -3 and g of -3 will be. So I'll do that up here. So f of -3, we plug in -3 everywhere where we see x. That ends up being -6. G of -3, plug in -3 everywhere where we see x. And -3 squared is 9. And subtract a -3 is the same as +3. So you'll get 12. And so that means here we would have -6 plus 12, which would end up being a +6 for their answer. All right, so for this question, we have the quotient of h and g, and we want to evaluate that at 3, which means we have h of 3 divided by g of 3. So if we look at h of 3, since this is h, we just plug in 3 everywhere where we see x, and we get 12. For g of 3, plug in 3 everywhere where we see x, and we'll see that we get 0. So if we do 12 divided by 0, we notice that we can't have 0 in the denominator, so anything divided by 0 is undefined. So that ends up being our answer for that. So, of course, in this example, I want to make sure that we understand that whenever we are evaluating these new functions that come from old functions, we want to make sure that we recognize when we're trying to evaluate this for, I guess, add a number that is in a domain versus when it is not. And of course, in this case, the new function that was created, its domain does not include the number 3. And specifically speaking, if we were to form this new function, it would look like this. So it'd be x plus 9 over square root of x minus 3. And of course here, like we talked about previously, we know that if we have the square root of an expression in the denominator, we know that this expression here, although we normally say it has to be greater than or equal to 0, we cannot have the equal to part, and thus we just have to have greater than, because if we plug in 3 here, we know that 3 minus 3 is 0, and square root of 0 is 0. So we can't have it equaling 3, so it can only be greater than 3. And so here the domain of this function would be all values of x that are just larger than 3. Hence why 3 is undefined. Hence why this function evaluated at 3 is undefined, because 3 is not in the domain. All right, so for our last problem here, we're just doing an application of creating new functions from old functions. And so what we're told here is that if we have some function r of x that means revenue and cost function c of x, then we know that profit is going to be the difference in between revenue and cost. So we see we have two old functions, revenue and cost, that produce a new function, profit. And so we're asked to first figure out what P of x will be. Of course, P of x, which is the profit, is going to be revenue minus the cost. So our revenue function is 60x minus 0.4x squared minus, and here, since we're subtracting the cost, and the cost is 2 terms, we have to put that in parentheses. And by doing that, there's an understood -1 that's in front of here that we're going to distribute to both terms, which makes both terms negative. And then from here, we will just combine like terms. And of course, oops, yeah, that's not right. So we got -0.4 x squared, and 60x and -3x are like terms. So we'll combine those. 60 minus 3 is 57 x. And then of course we'll have 12. So our p of x function will be this. Now, what we're asked to do is to figure out what is going to be the revenue when x is 90, the cost when x is 90, and the profit when x is 90. Now, if you remember, if we figure out what r of 90 is, and we figure out what c of 90 is, we don't have to necessarily plug in 90 into x here and here to figure out what it is. We can just subtract these two answers here, because we know that p of 90 is just r of 90 minus c of 90. Okay? So figure out what r of 90 is. We'll plug in 90 everywhere where we see x. Okay? And let's see, 60 times 90, that is 5,400. And 90 squared would be 8,100. And of course, from there, I'll go ahead and calculate. So we'll have 5,400 minus 0.4 times 8,100, which is 3,240. And if we take away 3,240 from 5,400, we get 2,160. So that should be the revenue that is brought in. For the cost, here we know that this is our cost function, so we just plug in 90 wherever we see x. 3 times 90 is 270. Plus 12, that'll be 282. And of course, to get the profit in 90, we would just take the revenue minus the cost, and that should be it. And again, no reason to have to go and plug in 90 into here and here. You can just calculate it this way. I already have the dollar signs there. All right, so once again, thank you so much for watching this video. I hope it's been helpful to you and learning what you need to know for section 2.2 in college algebra. Let me know if you have any questions. Take care.